When two black holes collide, the universe bears witness to one of the most violent and awe-inspiring events ever imagined. A cosmic clash between titanic objects that are capable of distorting space, time, and the very fabric of reality itself. This is no ordinary collision, it's a chaotic dance of death between two voracious giants, each capable of devouring anything that dares to cross their path. The calm before the storm, the binary black hole system. Long before the cataclysmic collision, the two black holes exist in a binary system, a pair of cosmic predators orbiting each other in a gravitational embrace. These black holes are formed when massive stars reach the end of their life cycles, collapsing under their own gravity to form regions where space and time cease to exist in any conventional sense. At the heart of each black hole lies a singularity, a point where density becomes infinite and the laws of physics break down. Surrounding this singularity is the event horizon, a boundary beyond which not even light can escape. In this binary system, the black holes gradually spiral closer together. As they do, they release energy in the form of gravitational waves, ripples in the very fabric of space-time that travel across the universe at the speed of light. These waves were first detected in 2015 by the LIGO Observatory, providing direct evidence of black hole mergers. As the black holes lose energy through these waves, their orbits decay, bringing them ever closer to the inevitable collision. The final plunge, when titans collide. As the two black holes draw nearer, the gravitational forces between them grow more intense, warping space-time to its breaking point. Their mutual gravitational pull accelerates them to incredible velocities, nearing half the speed of light as they spiral in tighter and tighter orbits. The space around them becomes twisted and distorted, a region of chaos where time itself stretches and bends. Finally, they reach the point of no return. The distance between them shrinks to nothing, and the two black holes merge into one. In this moment, the universe unleashes a storm of energy that dwarfs anything else in existence. The power of this merger is so great that it can briefly outshine all the stars in the universe combined, though not in visible light. This is an invisible explosion, detected only through the immense gravitational waves it produces. Gravitational waves, the silent roar of the universe. When two black holes merge, the gravitational waves they create ripple outward, distorting space-time like waves in a pond. These ripples stretch and compress the universe itself as they travel across the cosmos. Though we can't see them with our eyes, their effects are profound. On Earth, gravitational wave detectors like LIGO and Virgo pick up these waves as tiny shifts in the lengths of laser beams, movements smaller than the width of a proton. These waves carry away a portion of the black hole's mass, converting it into pure energy according to Einstein's famous equation, E equals mc squared. In some cases, the amount of energy released by the merger can equal the mass of several suns. This energy travels through the universe, offering us a rare glimpse into these hidden, violent events. The birth of a new monster, the final black hole. Once the merger is complete, the two black holes have become one, a new, larger black hole that carries the combined mass of its predecessors, minus the energy lost to gravitational waves. This new black hole is more massive, more powerful, and more terrifying than either of the original black holes alone. It has a new event horizon and a new singularity at its center, a point of infinite density where space and time cease to have any meaning. This new black hole may be spinning rapidly due to the angular momentum of its progenitors. The faster a black hole spins, the more distorted space-time around it becomes. In extreme cases, a spinning black hole can drag space-time along with it, a phenomenon known as frame dragging, where time itself is pulled into a whirlpool around the black hole. The dark side of the collision. What happens to the universe around it? The effects of a black hole merger are not limited to the black holes themselves. The violent release of energy can have profound effects on the surrounding universe. Any nearby stars, gas clouds, or planets that wander too close to the merging black holes would be torn apart by their immense gravitational forces. The collision might even trigger the formation of jets, streams of high-energy particles that shoot out from the poles of the black hole at nearly the speed of light, lighting up the surrounding space in high-energy X-rays and gamma rays. If a black hole merger happens in a region of space dense with gas and dust, it can stir up that material, heating it to millions of degrees and causing it to emit radiation across the electromagnetic spectrum. This radiation could be detected by telescopes, providing astronomers with another way to observe these cosmic cataclysms. The aftermath, a universe forever changed. After the collision, the new black hole settles down, its event horizon smoothing out into a nearly perfect sphere. The intense bursts of gravitational waves fade as the newly formed black hole reaches a stable state. But the universe is forever changed by this event. The gravitational waves from the merger continue to travel outward, passing through galaxies, stars, and planets, distorting space-time as they go. Over time, these waves will spread out, becoming weaker and harder to detect. But for a brief moment, the collision of two black holes sends a message across the universe. A message that tells the story of unimaginable destruction, the end of two cosmic titans, and the birth of a new, even more powerful entity. Time itself warped. Relativity at play. During the collision, strange effects predicted by Einstein's theory of general relativity come into play. In the extreme gravitational field near the black holes, time behaves differently. To a distant observer, the merging black holes would appear to slow down as they approach each other, frozen in time as they near the event horizon. This is because the intense gravity near the black holes warps space-time so much that time itself seems to stretch out. But for an observer falling into the black hole, the merger would happen in an instant, with no time to react or escape. This warping of time and space is not just a theoretical concept, it's a real effect that occurs near any massive object. But black holes take it to the extreme. As the black holes collide, the warping of space-time becomes so severe that even light itself is bent and twisted. If you were somehow able to survive near the collision, an impossible feat of course, you would see light from distant stars stretched and smeared across the sky, distorted by the immense gravitational forces at play. The bigger picture: black holes as cosmic sculptors. While the idea of two black holes colliding is terrifying, it's also a reminder of the incredible forces that shape the universe. Black holes are not just cosmic destroyers, they are also creators. When black holes merge, they help sculpt the large-scale structure of the universe, influencing the formation of galaxies, stars, and even planets. The gravitational waves they produce ripple through the universe, carrying with them information about the earliest moments of the cosmos. In the grand scheme of things, black hole mergers are part of the cosmic dance that has been going on for billions of years. They are a reminder that the universe is not a static place. It's a dynamic, ever-changing entity where destruction and creation are intertwined in ways we are only beginning to understand. The collision of two black holes is one of the most mind-bending, awe-inspiring events imaginable. It is a reminder of the raw power of the universe, a place where the very fabric of reality can be torn apart and reformed in an instant. These events are rare, but when they happen, they send ripples through the cosmos that we can now detect, giving us a glimpse into the hidden workings of the universe. In the aftermath of such a collision, a new black hole is born, larger, more powerful, and even more mysterious than what came before.